In this video, we're going to look at a two-step conversion between mass and particles. So looking back at the mole roadmap again, there are some times where we are going to be given a problem in terms of the mass, and we're going to be asked, well, how many particles are there? Or you might have a problem that asks, hey, you've got this many molecules. What's the mass of that many molecules? And so it's going to have to be a two-step problem, going from particles to moles, and then moles to mass. Or if you start with mass, going from mass to moles, and moles to particles. So this kind of problem is really putting it all together from this chapter. So here's an example of a problem you might see. What is the mass of 4.78 times 10 to the 24th molecules of nitrogen dioxide? So 4.78 times 10 to the 24th molecules. And we want to get that to grams, which is mass. So, but we can't do that in one step. It's got to be a two-step problem. We've got to go from molecules to moles using Avogadro's number. And then we'll go from moles to grams using the molar mass. So Avogadro's number tells me that 1 mole is equal to 6.022 times 10 to the 23rd molecules. And then since we're dealing with nitrogen dioxide, let's see, that's 1 nitrogen, and each of those is 14.01 grams. And it's 2 oxygen, and each of those is 16 grams. So that gives a total of 46.01 grams. So now that relationship tells me that 1 mole of NO2 has a mass of 46.01 grams. And so I'm going to use the relationship with Avogadro's number in one step. And in the second step, I'm going to use the molar mass to make this conversion. So when I set this problem up, 4.78 times 10 to the 24th molecules of NO2. I'm going to make 2 blanks, one for Avogadro's number and one for the molar mass conversion factors. And so I'm going to use Avogadro's number in the first one, 6.022 times 10 to the 23rd molecules in the denominator and 1 mole in the numerator. When I go check my units, molecules cancel, and I've successfully converted to moles. Now in the second blank, I have to use the molar mass. I want moles to cancel, and then want to be left with an answer in grams, so I put grams in the numerator. Moles are canceling. And so when I calculate this problem, and again, be careful with your calculator, make sure you use the EE or the EXP button when you're using Avogadro's number or anything else that's in scientific notation. So when I calculate this, I'm going to divide first by Avogadro's number, and then I'm going to multiply by the molar mass, and I get 365 grams of NO2.